Hello, my name is Jennifer Quinton. I am a member of the Decision Technologies software development team, and our team created this short video. We hope you find it informative. The purpose of this video is to introduce a Decision Technologies product which displays radar video in near real time. This software tool is irreplaceable when checking out a radar after initial installation, for pre-deployment testing, or for at-sea testing prior to scheduled formal testing. Often this tool will detect problems that will otherwise go unnoticed until after detailed data analysis, resulting in very costly retesting. This new product is a modification of a tool that we developed recently to display radar video using MATLAB as the development environment. Downsides to MATLAB include the expense of the initial investment as well as the maintenance costs required on each host computer. MATLAB is also very slow. The new design solves both problems. It is very fast and it runs on a computer without MATLAB installed. This new system is called RRAPLite. RRAPLite has the same functionality as RRAP. RRAP stands for Radar Reduction Analysis Program, and LITE indicates that it does not require MATLAB to run, resulting in a fast, inexpensive, and very portable system. This video will briefly describe the PPI and RHI displays, then describe controls for both. The display shown on the left is the PPI display, and the display on the right is the range height indicator display. The black lines shown on the PPI are targets. Both displays are typical radar displays in character, but are driven using extracted radar IQ data. The advantages are obvious. A file is replayable many times, serves as a gauge for radar performance, and provides a chronological record of performance for the date the data was collected. The PPI video driving this display was taken from the Taylor Hall radar in Virginia. Notice that the PPI source file includes date and time. This feature provides a perfect video log and can be used for years when investigating radar performance during testing or operation. As an example, what is the nature of land weather clutter when operating in the Red Sea? And how did the radar perform under these conditions? With this tool and collected IQ video in that region, the question can be answered. In this file, the radar mode is low E, which has a max range of 155 miles. The range marks on the PPI are at 25-mile intervals. The white line is the antenna azimuth marker and extends to the maximum miles in the given mode and rotates at the antenna rate. Using the zoom control for close range viewing can be very informative. Once you have zoomed in to the desired level, you can drag the video. At this closer range, you can view a target more clearly, and as the PPI updates, you'll notice the contacts updating. This feature enables detection position relative to video position. Differences indicate a bias or system offset. Setting the history panel on and entering 100 scans reveals a trail of tracks and video over time, essentially creating a storage display with user-selected hold time. This feature can be used to verify radar detection sensitivity and false alarm control. Using the Display Options panel to change which groups are being displayed provides insight that can be useful. As an example, selecting Group 1 changes the displays to reveal ground clutter and most weather clutter. Selecting Group 3 eliminates most ground clutter. This feature is very useful for recognizing ship's video reflections due to structure or antenna problems, causing excessive side lobes or main beam distortion. RRAPLite has ample controls enabling the user to identify, categorize, and measure video returns. An example of video returns for this particular day includes ground clutter to the north and south. Also shown are several buoys in the northeast. Severe weather clutter can be seen to the east, such as these clouds at range 28 miles, 15 miles, and 8 miles, as reflected by the cell data range output in the adjacent panel. Sea clutter can be found to the east. Clicking on a cell populates the cell data section of the panel with relevant information. Other types of video often observed are friendly interference, jamming, structure-reflected video, birds or low, slow-moving objects, and slide-low video. The window surrounding the two displays contains a menu bar and several informative panels. The menu bar is located across the very top and includes several controls and indicators. The File menu option can be accessed to load or restart a currently selected file. The Window option allows for customizing the window, including displays to show, radar information, or revealing the magnitude color bar. The Chart option reveals additional real-time display charts. This includes the elevation scan chart and the IQ histogram chart. The last menu option, titled About, is used to access the help feature of the software, which is the included user guide, or to view the detailed version information. It should be noted that the top of the window reflects the current version of the RRAPLite software. Below the menu bar is the File Data panel. This area shows the selected file name, current scan number, as well as a readout for roll, pitch, heading, and velocity offset. Next to the File Data panel is the Contact Selection panel. The associated drop-downs allow type selection, track-gated contact, and censoring options. As you've seen before, clicking the Display option button will open a new window that the user can interact with to select which groups and beams will be shown on the displays. MTI processing has 3 selectable beams and some additional features not found in non-coherent. This includes the option to view the radar displays with all pulses collapsed, 1 pulse at a time, or the second, third, or fourth time around. Selecting filters will enable a clutter comparison display that reflects the magnitude difference between filter 1 and the selected filter. Pausing this dynamic display reveals the current statistical information about the data. Lastly, the compass widget allows for quick reference of the ship's current heading. Each of the video displays has an associated control panel found to its right. The PPI controls include the zoom bar slider found on the left of the panel, cell data, which is populated by left-clicking on the display, target data, which is useful when an associated target or contact file has been uploaded. It provides specific information about the selected target. The cursor location, which indicates the current mouse position on the display. The range height sector is used to set the azimuth sector of the range height display. Right-clicking and dragging the mouse sets the sector. Targets appear on the range height indicator above clutter. Clicking Reset will remove this sector. Toggling Show Targets to Yes or No will show or hide the targets on the display. And finally, the Clear Display button will refresh the display and remove all kept history. The RHI controls are similar to the PPI controls. While the PPI display collapses the group or elevation video to form a range over azimuth display, the RHI display collapses azimuth video and displays the selected sector in a range over height display. Just as with the PPI, left-clicking on cells or targets in the RHI will populate information in its control panel for viewing. In summary, RRAPLite provides a portable tool that can be used during all phases of radar testing. This tool enables on-the-spot radar verification before or after at-sea testing. RRAPLite development costs are insignificant compared with the cost of a single at-sea test failure due to undetected equipment problems or severe weather conditions in the test vicinity.